I'm trying to keep it very precise and to the point. Uh, Coming to the popularly known technology of pulse oximeter, which is derived from PPG. Um, so PPG is a optoelectronic method of getting a volumetric change in the exposed area of organ. Generally, it is being used in the periphery of a organ like a fingertip, or sometimes in a reflectance way in wrist region, or in a form of a ring. It could be used in earlobes or different other positions. What generally it works on is illuminating the region with. Hello. Yeah. So
Yeah,
how
fine.
it works is that there is a illuminating source. Generally, it would be LED, and there will be a sensing device, which will be a photodiode. The illuminating source LED will have a wavelength ranging from between in the visible range as well as in the uh, near infrared range. Visible range mostly will lie from 500 nanometer to 750 nanometer, and infrared range will lie from 750 nanometer. It can go till 2000 nanometers. Very, very unlikely seen
Yeah,
to move above 1000 nanometer. Somebody's mic is on. Okay.
report
So
ತೋರಿಸ್ತೇನೆ ಅವತ್ತಲ್ಲಿ.
So generally, pulse oximeter uses the technique of using one wavelength in the red region. It could be 660 nanometer, and one wavelength in the infrared region. It could be 930 nanometer. It works on the principle of Beer-Lambert's law. I'll come to the Beer-Lambert's law, and generally this could be fitted at different positions like finger, wrist, earlobe, toe, etc.
Yeah.
Why this is not
ಇಲ್ಲ
used in
yeah.
the uh, lower wavelength of the visible is because these lie in the ultraviolet region, and there could be regulatory schemes for not using that wavelength. And similarly, it could lie for higher wavelength also, that there could be some regulatory uh, reasons for not using higher near infrared regions also. So the pulse oximeter, as I said, uses the wavelength in 660 nanometer and 930 nanometer, 914 nanometer to get the blood oxygen saturation level. General scheme, or the general the pathway of getting pulse oximeter could be this: that there is a sensing source, uh, and then there is a hardware to get the signal, and then there is a signal conditioning, there is a signal processing element which extracts the signal, and then there is a algorithm which detects the various parameters like heart rate or SpO2, which is blood oxygen saturation level. So coming to the components, before that I would give you few more uh, understandings of PPG. So basically, the PPG could be in uh, two different modes. One is the transmittance type, and other is the reflectance type. Transmittance type is the method in which the source, which is the LED, will be above or at one side of the exposed organ or region, and the detector, which is photodiode or photodetector, will be on the other side of the exposed region. So the light source passes through the exposed region and gets detected in the photodetector. And then there is a reflectance type method, which have which has the source and detector in the same location, same side of the organ. So uh, yeah, so like from the mechanism itself, it could be prevalent that where it could be used. So transmittant types are generally used in the finger periphery. So if you would have been to any hospital or any clinic, you would have seen people using clinicians using the finger photoplethysmograph for the pulse oximetry purpose application. Uh, and reflectance type, it's very commonly now seen in the smart wearables. If you have a wristwatch, smartwatch, smart ring, or a smart eyewear or something, it will have a generally it will have a reflectance type of a PPG. Uh, Transmittance type can also be used in various other regions like earlobe. And for example, if the transmittance type is used for a neonate, so neonate, I mean the newborn baby, uh, the newborn baby may not have uh, that liberty to use a big sensor or a very complex sensor. So a very delicate sensor can be used in like in the leg position or in the toe. Uh, Reflectance type also can be used in various other regions and various other forms. Like there could be a remote kind of reflectance uh, PPG also, which could be used on face or neck or etc. There are certain other ways. For example, certain developments are seen to use photoplethysmograph inside the ear into the form of a hearable. Means if you have a if you have a earphone or something like that, it can the PPG sensor can get inside the cavity of the ear, and there also the sensing can happen. And various other methods are getting developed and used for various applications. These are some commonly commercially grade devices available in the PPG. Coming to the principle of working of PPG. So the principle of working of PPG lies with the Beer-Lambert law. It's a very old method of getting light responses passing through a medium. So what this law says that the rate of decrease in the intensity of light propagating through an absorbing medium with thickness of, let's say, X, is proportional to the intensity of the light. What uh, in easy word it means that uh, as the light, an illuminating source, progresses through a absorbing medium, the intensity of the light decreases, and it decreases in this way, based on this formula. So attenuation depends on the concentration of the medium, the distance or the depth of the medium, and attenuating or extension coefficient, which is given by epsilon here. Uh, so a transmitted light or a reflected light will have this representation, which is IT is equal to I0. I0 is the initial light given into exponential of minus epsilon dc. So d is the path length and c is the concentration of the medium, and epsilon is the extinction coefficient. There has been a modification and updates in Beer-Lambert's phenomenon, and uh, a factor of scattering is also added. If there are multiple absorbers in the medium, then the mechanism can go with the various, means it's in a summation form, that the absorption happens for each and every medium in a summation form. So this is the basic idea of how the PPG works. This idea is actually manipulated to develop various application and uh, algorithms for PPG, and whatever we see in the consumer domain works on the same idea. So there are various components in the skin tissue of a user. So when a light illuminates a specific portion of the skin, there are different portions which absorb the light, and the reflected uh, or sorry the absorbed light at the detector will be a combination of all these components. So at the very basic level, there are very static or static remaining components, which are skin, bone, and tissue. So because of this, there will be a DC or a uh, very unchanging kind of a signal pattern coming in the signal, and then there will be effects due to capillaries, there will be effect due to veins, and then arteries. In combination, what you see